Today I'm going to show you how the variable valve timing system works on your engine. Now, variable valve timing is used to control the intake and exhaust timing for a more cleaner, efficient burn, less harmful pollution, as well as more power. So just a quick overview of how the engine's set up. We've got the head here, which is what I'm going to be showing you today, and inside of that we have your intake and exhaust cams that move up and down. Then when the combustion happens inside of the cylinder, the piston will move up and down, and that turns the crankshaft at the bottom. Now on this engine here, we've only got variable valve timing on the intake side, which is the front side here, where the air enters here and the fuel will enter from here. This side is the exhaust side, and that does not have a variable valve timing gear. Now in an engine, you've got a piston that'll move up and down, and that will turn the crank near the bottom of the engine. Now at the top of the engine we have these camshafts that control valves. Now when this camshaft rotates, it's got this lobe on it that will press down on that valve seat, and that will in turn open a valve down here, allowing air to enter the engine for combustion. So there's four main cycles that happen inside of the engine. The first stroke will bring in fresh intake air as the piston moves down. Then the piston will move back up for your second stroke, compressing that air. Then it will combust, causing the piston to move back down again. And then finally the piston will move back up and push all of the exhaust gases out the exhaust valve. Now the crank down at the bottom of the engine is connected to the two camshafts through a timing chain or a timing belt. Now without variable valve timing, the timing of your valves are actually fixed throughout the rev range of the engine. No matter how low or high RPM you're going, the timing of the valves being opened and closed are exactly the same. So now in order to optimize valve timing, we've got this variable gear here that can change from its input, which is the teeth, and its output, which is the camshaft here, to either advance or retard its timing. Now it's worth noting that this type of variable valve timing can vary infinitely from 0 to 15 degrees or so, whereas in other systems there's a completely different cam profile that will follow when the timing is changed to increase either the duration or the peak that the valve will open into the engine, but that's a fixed timing. So I'm going to open up this variable valve timing gear to show you how it can vary from the input to the output shaft using oil pressure. Now if you look inside of this camshaft, it's actually got two grooves here. That groove there with the hole will lubricate the bearing that sits inside of here where this rotates on, and then this deeper groove here will allow oil to enter the variable valve timing gear when the timing needs to be changed. Now you also know that there's two holes, one over here and one over here, that supply oil from the engine's oil lubrication system. Now the one that goes to the variable valve timing gear is controlled by your oil control valve over here. Now what's interesting here is you've got these four pentagon shaped fasteners here that hold the face onto the variable timing gear, so I'm going to just remove these four bolts. And now once I remove this front plate, we can have a peek at what's inside here. So inside of here you can see we've got four pockets where oil would normally fill up in order to advance the timing. Now we've got this little plunger here that locks the input, which is your gear from your timing chain, to your output, which is the centerpiece that goes out to the camshaft itself. And then I come in with the pliers, I can remove this plunger. And you can see with the plunger out of the way, I can rotate my input shaft relative to my output shaft, roughly about 15 degrees or so. And you can see that these four pockets that are formed when I move it are actually going to fill up with oil, and that will cause this relative motion between the two. Now keep in mind here, with your input and output shafts are still rotating relative to each other, that this entire camshaft is rotating around and around, which keep your valves moving and hence your engine running. So therefore what it's doing is basically advancing or retarding the timing of these cam lobes, and hence the movement of the valve within the combustion cycle. Alright, now I'm going to pop off the center bolt here, and then I can remove the guts of this variable valve timing gear to see how it works inside here. Now you can see that your input from the chain is actually rotating relative to your output, and it's got a peg here that'll lock onto the outside of this valve timing gear here, and then on the inside here we've got another peg that'll lock to the inside of this, and this inside piece here is what's responsible for creating that angular retard or angular advance in the timing of the valves. Now you might be wondering, how does this thing get fed oil? Well, if you remember, we've got this little hole that's drilled on the inside here, and that brings oil from the engine block, which is controlled by your oil control valve. Now that will enter into here and will come out through these four little exit points here. That'll fill up these four chambers that you saw mentioned earlier. Now when this thing starts to fill with oil, the first thing it's going to do is pop in this plunger here. It's got this little passageway that'll pop in this plunger with oil pressure, and that will unlock the input shaft from the output shaft. And now this side of the chamber here will start to fill with oil, and that will advance the timing a little bit. And as you keep filling this with oil, you can see that it will max out at some point, and then these chambers will fully have oil pressure built up in them. Now, if you relieve that oil pressure, that's how you bring your timing back down, and then that'll bring you back down to the home position, just like that. Now, if I open this up here, you'll notice that they've actually got these little plastic sliders that go around the outside of the gear, and that's just to help with friction. And as I remove them, you can see that these sliders are coming apart, and they've got these little springs on the back there that help keep it pressure. So just to explain how variable valve timing can work to your advantage, for example, if you were to close your intake valve late, i.e. the piston is moving up, some of that air and fuel mixture will actually move back into the intake plenum, and that way you can control the amount of air and fuel that you burn in the combustion cycle, therefore making your combustion cooler, you're polluting less, and you're also using less fuel. This especially works better at low RPM when you don't really need all the power. Now in this scenario, you would open your intake valve a little bit early when your piston is pushing up on the exhaust stroke, and that would push some of the exhaust gases back into your intake plenum to be reburned into the next cycle. And that kind of works just like EGR by reburning your old exhaust gases, therefore reducing your combustion temperature and your nitrous oxide emissions. Now let's say you were able to delay the closing of your exhaust valve a little bit. Well, that's going to create a little bit more flow for the exhaust to move out, and you're going to get the maximum amount of power from that piston stroke. It'll also create a little bit of a vacuum for more intake air to go in for the next cycle, resulting in a much more powerful stroke, especially at higher RPM. Now you might be asking yourself, well, how does the engine's computer actually monitor how much the oil to put into the variable valve timing gear in order to optimize combustion? Well, the answer to that is through this oil control valve here. Now, if you remember my oil lubrication video, the oil pump actually sits on the bottom of the crankshaft and rotates, which creates oil flow, but not oil pressure. Now, what creates that oil pressure is when the oil will flow through small orifices and passages in the engine. That creates oil pressure. Now, in this case here, we've got oil that will flow up to the head here, and it branches off into several locations. You can see that one of those passages actually goes slantways through to the exhaust cam, and then it's got another passage that goes up to lubricate the intake cam bearing up here. Now the one that we're actually interested in is the passage that goes to the oil control valve, which goes up right here. Now the oil control valve is basically a solenoid that'll move back and forth, and that's just basically a redirect for that oil pressure that's coming up over here. Now we can redirect oil pressure to go from here over to the VVTi gear into that hole to fill up the gear and therefore advance the timing as we saw earlier. Or it can work backwards and relieve the pressure that's inside of there when you want to retard the timing and release that oil back into the lubrication system. Now if you look closely inside of your oil control valve hole, you can see there's actually like 4 different oil passages, and that's to allow oil in, oil out, oil to the gear, or to bleed off the gear. Now if you look closely as I apply 12 volts, you can see that the oil control valve is actually moving back and forth to redirect oil. Now your input shaft and output shaft are actually 2 separate pieces. As I take them apart here, you can see that there's actually these oil grooves on the inside here and inside over here. Now the next question you might ask is, well, how does the oil control valve know how much oil to fill into this variable valve timing gear in order to advance or retard the timing? Well, the answer to that is by the computer here, which controls the input of your oil control valve. But it's also got an output here from this Hall effect sensor, which is your cam position sensor, that measures the position of the camshaft exactly, so it knows, relative to the crankshaft sensor, where the combustion cycle of each cylinder is and how to advance or retard the timing. Now this is a Hall effect sensor that measures the cam position, and you can see there as I rotate it, it actually changes voltage here, and that's how the ECU knows exactly where it is by measuring the voltage. And that's pretty much how the variable valve timing in your car works. Make sure you subscribe if you want to see more videos just like this.